NASA has just denied an idea that will leave you speechless, the possibility that wormholes could be used as a shortcut through time and space. The technology they've developed is so advanced that it creates a wormhole. This is not so insane. In this video, we will be talking about the revealing of a portal and the creation of space-time modification technology by the US Navy. Stay with us till the end of the video to know exciting information. A wormhole. What is it? Explore with us one of the universe's most fascinating and puzzling occurrences. Think of it this way. You're at one end of a tunnel, and your goal is at the other end, but it's too far to walk. What if, however, we told you there was a secret passageway within this tunnel that might take you directly to your destination? That secret passageway is a wormhole, and it exists only in space. A wormhole is a tunnel across space and time that is a specific solution to the equations explaining Einstein's theory of general relativity. The wormhole serves as a short route between the two locations, provided that its length is less than the total distance between them. Although wormholes are frequently featured in science fiction and also have captivated the public's imagination, these portals remain theoretical at this time. Although wormholes are theoretically possible solutions to general relativity, scientists have yet to discover a mechanism to keep one open in the real world. The missions for the searching of evidence of wormholes. A wormhole is essentially a fold in space-time, like a crease in a piece of paper, which allows for a quicker connection between two faraway locations. The plot thickens now. Since time is also a dimension in space-time, scientists think these wormholes could be exploited for time travel as well. This means that if you went through a wormhole from one end to the other, you might end yourself in a completely different era and location. Although extremely powerful wormholes are still only a theoretical possibility, they could provide us with a look into the universe's potential. And who knows, maybe one day we'll be able to harness its power and discover the universe's secrets. Is NASA seriously trying to find wormholes? The answer is an emphatic yes. For decades, NASA has been at the front of efforts to learn more about the cosmos and find proof of anomalous phenomena like wormholes. NASA has been working tirelessly to learn more about the cosmos and the rules that control it. And this includes sending spacecraft to the farthest limits of our solar system and researching the behavior of black holes and other celestial phenomena. As part of this procedure, they have been looking for wormholes, which could provide a way to travel through time and space. The deployment of the Hubble Space Telescope was a particularly thrilling mission in this pursuit. Black holes, which may serve as wormhole entry and exit locations, are among the far-flung and unusual phenomena that the powerful observatory has imaged. With the launch of the James Webb Space Telescope in December 2021, the search area was further expanded, but to no result. The fact that the JWST builds its images using waves in the infrared and ultraviolet spectrums is also irrelevant. We would have seen it regardless of its visibility. While NASA hasn't produced conclusive confirmation of the existence of wormholes just yet, the agency has been utilizing sophisticated simulations and models to investigate the phenomenon and its possible presence. NASA's inability to uncover a wormhole, despite extensive searches, must have been disheartening, so the organization decided to begin developing its own wormhole. The creation of a wormhole. We must first have a firm grasp of the fundamentals of physics, especially as they pertain to gravity, space, and time. In order to create a wormhole, we must first understand the nature and structure of space-time and the necessary materials for doing so. Then, we have to find a way to power ourselves through the enormous gravitational forces which would surround the wormhole. This power would have to be on par with that of a star or black hole in size. Finally, we'll need to figure out how to keep the wormhole from collapsing in on itself. Exotic matter, which has strange properties and a negative energy density, would be needed for this. When you consider that just a few decades ago, it seemed unthinkable that a single scientist would be able to create a wormhole, you can appreciate how far we've come. Sycamore Quantum Processing System. Maria Spiropoulou, a physicist at Caltech, and her colleagues recently made headlines with their discovery of a newborn wormhole. Although the groundbreaking research was published in Nature, the prospect of actually transferring living organisms through a wormhole remains quite remote. The physicist John Wheeler coined the term wormhole in the 1950s. Remember that, according to Albert Einstein's general theory of relativity, a wormhole is a rip in space and time that connects two distant parts of the universe. In the experiment, the wormhole dynamics were seen using a quantum gadget developed by Alphabet, dubbed the Sycamore Quantum Processor. Important characteristics of a gravitational wormhole were observed in a quantum system that was compact enough to be constructed on existing quantum hardware. The experiment did not actually tear a hole in space-time open, but researchers saw what appeared to be a wormhole open up as a result of teleporting quantum information using quantum codes just on a quantum computer. Despite the encouraging results, the researchers stressed that theoretical possibility and practical feasibility are not the same things. Yet, they are ecstatic to have the chance to investigate these fundamental cosmological issues in a controlled laboratory environment. Baby Wormhole describes the current size of the wormhole. Worse, it exists only in simulation. No physical version has been made, and given how challenging it was to develop even this simulation, building a real-life wormhole appears just as impossible as it did before. We don't know how much time it would require scientists to execute it, but given that they were able to simulate a stable wormhole, it can't be too far off. If we possessed wormholes, we could travel to the farthest regions of space in a matter of minutes, discover new worlds, and even witness the Big Bang itself from a unique perspective, and that's only the beginning. There would be no need for long, tiring flights or hours spent in traffic jams if we all started using wormholes to get around the world. The possibilities of wormholes go far beyond just transportation, so don't limit yourself if you think they're only useful for getting from point A to point B in a hurry. Experts think these rifts could even be exploited to travel through time. Understanding the connection between wormholes and black holes. Even if the word hole is shared by both the wormhole and the black hole, that's about all the similarities between the two exist. To begin, let's discuss black holes, which are extremely enormous and gravitationally powerful objects in space from which not even light can escape. Any star, gas, or dust that comes too close to a black hole, created when a star collapses in on itself, is destroyed forever. Scientists are still trying to understand the features and behavior of black holes, but they are interesting phenomena. We've previously given you a complete rundown on wormholes, so let's focus on what makes these two things distinct from one another. Therefore, to begin with, black holes are actual and have already been observed, whereas wormholes are still only a theoretical possibility. What makes black holes so intriguing and mysterious is their intense gravitational pull. Yet, wormholes are characterized by their ability to connect disparate locations in the universe and aren't typically associated with substantial gravitational force. The size of a black hole also varies widely, from just a few miles to millions of kilometers, whereas wormholes have a fixed diameter. But wormholes are expected to be significantly smaller and perhaps much more challenging to identify because their size is not understood. To put it another way, if we enter a wormhole in an effort to find a means to prevent extinction, we will end up in the past when there is nothing left on Earth. It will be a massive undertaking to start over, but at least we will know better next time. Now we know it's practically impossible to confuse a wormhole for a black hole, but let's pretend we do anyway. We'd be swept into an infinitely deep abyss. Since no one has ever returned from a journey to a black hole's center, nobody knows for sure what it contains. However, the general consensus is that it is unending nothingness. Anything that enters a black hole will be destroyed by immense gravitational forces. That's all for today. Thank you for watching. If you enjoyed the video, do like and subscribe to this channel.